things are a bit more exaggerated in roots. The lengthening process takes apparently longer. But the process is the same. You have an apical meristem, those cells divide real fast, then you're going to produce ground, vascular, and dermal tissue. You have the same names. Ground meristem, procambium, protoderm. Can you see the procambium? Yes, in much the same way you could when you looked at the stem. You're looking for the stripes. Okay? So, apical meristem. Now, as this process goes, now in roots things look a little bit goofier because you also have that regional terminology. The regional terminology. So, this is the region of cell division. And then you get a region of differentiation. So now you're starting to see what's going on. So you've got ground meristem, you've got procambium, the edge is the protoderm, much like it was in stems. You guys with me? Here, this is trying to show you that. That's the meristem, that's the cap. That's way too close. What are those? So what region are you in? Maturation is where your root hairs are. You guys with me?
Let me see the last, sorry.
No worries. So you're at maturation. As you can see the root hairs. How can you tell differentiation from elongation regionally? Take it literally. In the elongation, the cells are starting to elongate. In differentiation and cell division, they're square and rounder. And then they elongate, and then when the root hairs, it's maturation. Okay, so take that region of elongation literally. You guys with me? Monocot or dicot? Okay, so the very first thing you should be thinking before we do that, root or stem? How can you tell it's a root? Root hairs is a pretty good clue. You won't always see those.
The endodermis.
The endodermis or the Casparian strips. Okay, that tells you it's a root. What's the function of this?
Keep water.
Keep water in. So remember, the root hairs, and this was something that we hit on a little bit on that lecture test, and it was pretty important ideas. The root hairs are busy doing active transport. The water follows. You just blew a bunch of energy to make sure you're extracting the water out of the soil. So as that water's moving up the cylinder of the root, you don't want it to go back out laterally and follow its diffusionary gradient. So you put this in here. It tells you you're looking at a root. So monocots and dicots both have the Casparian strips or the endodermis. All right. So monocot, why? Monocot roots have a ring-like distribution of the vascular tissues. Can you see the xylem? Can you see the phloem?
Yeah.
Probably a little far away. You can see the xylem here. That means the phloem's kind of intermingled amongst it. What's this? Okay. What type of tissue? Out on the edge? Epidermis. And so the root hairs are single epidermal cells stuck out in the soil. What's going on here? Same thing that's going on here. What are these things? Lateral roots. So let me back up. This is really fuzzy. I know some of you are taking pictures. I'll come back to this, I promise. Lateral roots typically emerge from right on the edge. The layer of cells directly under the endodermis is the pericycle that's giving you the lateral root. That's a bit weak. You're going to see it more exaggerated like you see on You're going to see it more exaggerated like you see on 66. Okay, now another reason to look at this photo. Now, can you see the xylem and the phloem? Okay, xylem's here, the phloem's here, parenchyma's here. And again, this is the, so you know this is a root or stem. And so if there's a choice of leaf, are you going to choose that? Please don't. That's the red herring in there. Don't choose. No more leaves. Okay, much more exaggerated. Monocot or dicot? Monocot, right? You still have a pit. Now, this one, if you were guessing, you'd probably go, okay, this is probably a bit more xerophytic because there's an endodermis. It's this outie. It's very, 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 very thick. Again, you can see the xylem, you can see the phloem kind of intermingled amongst. See the parenchyma, more parenchyma. Yes? More of the same. You can see the xylem bundles here. Here, this particular species, the xylem tends to coagulate evidently. You see some xylem here, you can see the endodermis. That's probably sclerenchyma, not testable. And you can see the phloem. So what's really testable here is the endodermis, xylem, and phloem. You guys with me? More of the same, right up close and personal. So, what tissue are you looking at here? What's this? What's this? That makes this the... Alright. Root or stem?
Can't tell.
Could you tell if it was a monocot or dicot at that level of magnification? No, probably not. Are you bored with that yet?
Yes.
Okay, good.
Dicot.
Dicot. How can you tell?
Star.
Marks the spot.
X marks the spot. What is the X or the starfish shape in there? Xylem. So that means right here in these edges. Can you see? Now some of you may be thinking, wait a minute. Root or stem? Root or stem? How can you tell? You see the endodermis. Now some of you may be going, that endodermis is kind of weak. Yeah, why? All this other hoo-ha kind of helps block that out. But you can see it, yes? Can you see the endodermis? I think this is like a herbaceous monocot stem. Dicot roots are real obvious. There's not a lot of confusion, I think, because of that X or that star. You can see the endodermis, you can see the xylem, so that makes this the phloem. You guys with me?